Right, so in the last class we looked at the charging circuit in practical way, how to check the charging circuit, how to check the battery charging, how to check the EC communicating with the battery, and how the charging mechanism works, right? And how the battery is being charged. And when the battery is full, the IO controller will send the adapter cutoff signal to stop the two input MOSFETs, or the protection isolation MOSFETs, to stop the charge so that the battery will discharge. And I showed you how to check the MOSFET and how to check the battery MOSFET for discharging and when it's charging. Alright, so in this class we're going to do 5V and 3.3V regulator IC, right? And we're going to look at the differences between the equivalences of these ICs which you can substitute. We're also going to look at the data sheet and to understand different pins of the IC, right? The different pins that is used for each function for 5V and 3.3V regulator IC. Step by step, the working conditions of each 5V and 3.3V regulator IC, and how to determine faults, fault finding, and come to a conclusion to the fault, right? So in this class, this is a practical way I'm going to show you with the use of the oscilloscope. We will use this oscilloscope where we're going to check the PWM circuit, the PWM circuit which we're going to use to check and understanding the whole idea of a pulse width modulation and what is a PWM, right? And why is it important for digital electronics now and for the future, and which is a suitable way to provide power to different devices on a electronic device, not only a laptop but other electronic devices which use a pulse width modulation design or artificial type of circuit to provide power delivery to the different chipsets. And we're going to use oscilloscope how to check a PWM circuit in a basic way, and then remove a slight more advanced way of using the oscilloscope to check PWM circuit, right? Now I have here a small handout here of introduction of a pulse width modulation or PWM circuit, and it says here PWM, pulse width modulation, right? So the width, pulse, the width, which is the time, how long it will last, and it is a modulator, which is the amplifier, which is the switch, which is switching the MOSFETs. So that is why a PWM circuit on a laptop motherboard is generally composed of a PWM chip, a MOSFET, and the coil, and a capacitance, right? So in this class, I'm going to explain the 5V and 3.3V regulator on this board. This is our case study board that we're using from the last couple of months in classes, from the theory now to the practical, right? And this is the 5V and 3.3V regulator. This is the 5V and 3.3V regulator IC, right? This is the 5V and 3.3V regulator IC, and we are going to use the schematic and we're going to trace it out practically live and to show you how to check a 5V and 3.3V regulator IC. I also have here the data sheet of this IC, which is the RT8205A. You have B and C, right? And it says it's a high efficiency main power supply controllers for notebook computers, right? So the RT8005A, B and C is a dual step down. You know what that means? You know what dual means? It is a dual pulse width modulation circuit. One for 5V and one for 3.3V, right? And it is a step down because why is it called a step down?
Because it's taking it from 19V.
Beautiful. So it's taking it from a 19 voltage, from a higher voltage to a lesser voltage, right? So it's a dual step down switch mode power supply controller, generates a logic supply. You know why it's called a logic supply? The output is not fixed. The output is not fixed because it is working in an adjustable way. So on a board you might 3.3V, on the next board you might have 3.4V. Let's show you. Let's go to the next coil. Normally on some boards you will find 3.3V at this coil. See, I'm measuring this coil, PL302. Let's go to the schematic, right? PL302, see the schematic? PL302. Sorry, the next one. PL302 and the output is 3 volt always. Power, right? So let's check PL302. See? 3.4 volts. So on some boards you might see 3.3. On some boards you might see 3.2. But for this one it's 3.4 volts. So this is basically showing us that the output is not fixed. The output is not fixed because this chip can act in an adjustable way. So the output of this board is 3.4 volt. On some board you might see 3.3 volt or 3.2 volt, right? So the output is not fixed. So that is why it says it's a logic supply voltages. Battery powered system. The RT8205 includes 2 pulse width. See that? The RT8205A, B, and C includes 2 pulse width modulation controllers fixed at 5 volt and 3.3 volts or adjustable from 2 volt to 5.5 volt, right? An alternative L gate output LG1_CP can be used for an external charge pump. And that's it for now for the 5 volt and 3.0 volt regulator. And we have checked the entire working sequence, and we're going to use the oscilloscope to check the output of the PWM circuit. Remember, it is voltage over time, and we are going to measure with oscilloscope the PWM circuit. Alright, so we're going to check now. Alright, here. Right, and we are going to check for skip and PWM mode. How we can identify the difference between the both of these modes. Every PWM chip has the way to adapt to different state based on the state of the computer, right? To conserve power. Good. Right. This is the skip mode.
That's it?
This is the skip mode, right? This is called skip mode. So this is basically telling the laptop this is in off mode, and this signal is basically telling the PWM this is one of the PWM mode to adapt. This is called the skip mode.
So this correct?
The frequency of skip mode, yes, is perfectly right. So the frequency of skip mode is I said, is 36.6 kilohertz. If I check the next side, you see that? One side of it is giving us what? Skip mode. Turn it up now, and you see the output. No, you turn it down, turn it up. Yeah, again. Yeah, see there? Good. So that's it. So this is the perfect waveform when we zoom in out more on the waveform. So we get a lot of noises on this side. And if I measure the output, it should be a smooth line. See?
Touch it again.
Right? So this is the back side. And this is the left side of the coil. And on the right side, we should get this. 3 volts. Steady 3 volts. Alright, the board is on.
Okay, I like that.
The touchpad. We're going to check. See, look at that noise. So we have more noises. Turn it down for me, turn it up. Alright, turn it up now. Good. So this is it. Now, this is PWM in full duty cycle. 100% duty cycle. Now we have more noises that is generated. Right, see?
Sure.
No, more noises generated. Check the next side. Smooth. So the filter capacitor is working. If you check the next side, this is PWM in its best action, and the gate also is the same. And this is how switching works. Switching on off, on and 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 off in a cycle. So that's it for 5 volt and 3.3 volt regulator. I hope you understand it. This is the correct step of how to check a 5 volt and 3.3 volt regulator using multimeter and with the oscilloscope to check the circuit of a PWM. And in the next class, we're going to do the working conditions of the I/O controller, how the BIOS is being communicating with the BIOS, how to use the oscilloscope to measure the BIOS pins to ensure that the I/O controller is correctly reading the BIOS, right? And the adapter present signal, the supply, reset, and clock. And then we're going to go to the trigger. We're going to learn how to understand the resume well reset or the RSM reset signal, which is going to the PCH to start the first reset signal on the board. So RSM reset is the first reset signal that is generated right after the trigger. that is we're going to do in the next couple of classes. So the next class we're going to do the I/O controller. What is our microcontroller? What are some of the different functionality of a microcontroller which give things their intelligence and to control a very logic and complex circuit. So any circuit that has a lot of logic inside it needs a microcontroller in order for it to perform correctly. That's the beauty of a microcontroller, which is the I/O controller. Right, so we're going to look at the I/O controller in the next class, how the I/O controller reads the BIOS, and after reading the BIOS, it